Hello, welcome to area of a trapezoid. For this lesson, you are going to need a ruler, a pencil, and a pair of scissors, and some paper. It can be scrap paper, it can be colored paper, it can be graph paper, any kind of paper that you need. So we are going to be talking about area. So we're going to begin by defining those terms that we need to know. And we're going to go back to our rectangle because we always go back to our rectangle when we talk about area. And the reason for this is because a rectangle has neat squares that you can actually use as your square units. So, and like every geometric shape, it has a base and a height. And when I flip it over, the base and the height are the same. So this is a rectangle, and the terms that we're going to use, very important when you're taking your notes, are a capital A for area, a lowercase b for base, and a lowercase h for height. And you've done area lessons before, so just to go back, review, area of a rectangle and a parallelogram, and you know why that works, is always going to be area equals base times height. Another way to write that, the little dot means times because we're using letters. So if I put an X in there, someone might think that you're multiplying three variables together like we're doing in that bottom one where it says base times height. I've taken out the times sign and it still means base times height because two variables, two letters representing numbers put together, you multiply them. So there are three kinds of trapezoids, and I want you to think about that for a moment. What are they? Do you remember? We were actually in a lesson. I would be challenging your memories right about now. As it is, can you think of them? All right, I hope that when you thought about them, you came and you thought of this one. This is, because it has a right angle, a right trapezoid. Another common trapezoid, kind of related to our triangle, is an isosceles trapezoid, which has two congruent sides. So this is an isosceles trapezoid. And finally, we just have a scalene trapezoid. None of these sides are the same length. So just like a triangle that has no congruent sides, or a scalene trapezoid has no congruent sides. So one thing that all of these trapezoids share, though, is the fact that they have two parallel sides. So the problem, however, with this trapezoid is just like a triangle, and I'm going to use this one just to show you, because this one you could almost measure like you do a rectangle. However, if you look at this, you're getting some partial squares there. So you can't just go ahead and count your square units because, like a triangle, not all of the units that you see in this grid are square. So we have to find a way of turning it back into a rectangle. So that's what this lesson is about. And I'm going to start by just reminding you these are the spellings of the kinds of trapezoids that we're going to work with. And I'm probably just going to show you on one or two. But your goal when you do this lesson at home is to see if you can make these formulas work for all trapezoids, all the three different kinds of trapezoids. So you're going to have to do quite a bit of cutting. So I'm going to start first with my right trapezoid. And you're going to see some similarities here with some other lessons that you've had. So I'm going to take two congruent right trapezoids right here. See, this looks like one right trapezoid. It is actually two right trapezoids. Now, you'll notice I can't just flip these over, right? That is because it actually has two bases. If I turn it this way, I have one base here. We're going to call that the big base because it's, well, it's the longer of the two bases. If I flip it over, well, now this is the other base. And we're going to call this the little base because it's the shorter of the two bases. But at any rate, a trapezoid, no matter what kind of a trapezoid, has two different lengths of bases. So we have to take that into account. So right now, I have two congruent trapezoids. I want to find the area of one trapezoid. The first method that I'm going to use is, because I've got two and I want to find out one, I'm going to see if I can get them to fit together. It doesn't work, that just gets me another trapezoid. But if I flip this over and put these together, I now have a rectangle. That's my goal. And if I look at the base of this rectangle, you'll see that it is the longer base plus the shorter base of one trapezoid, and the height is the height of one trapezoid. So the area of this big rectangle is the same as the area of two of these congruent trapezoids. So I know that the area of this rectangle is big base plus little base times the height. So if I want to find out the area of just one of these, all I have to do is divide that by 2, right? So big base plus little base times height divided by 2. So I'm going to take half of the base times the height of the big rectangle. So that formula looks like this. And you can write that down, but try to do it at home with some paper and some scissors, all right? Because that'll really make it make sense to you. So we have big base plus little base times the height divided by 2. So big base plus little base times the height divided by 2. So I'm taking the length of both bases, the full height, and then I'm just dividing that whole thing by 2, and I have the area of a trapezoid. I'm just going to show you how that works with these two isosceles trapezoids. So I have my big base. I'm going to add my little base. And now I've got a parallelogram. Hey, we also know that a parallelogram has an area of base times height, right? So the height on this parallelogram, though, goes from the top, and you have to measure in a congruent or a perpendicular line from the top of the shape to the base. So base times height divided by 2. So in this case, big base plus little base times the full height divided by 2. All right, so that is the first way to find the area. But sometimes those numbers are a little hard to work with, so we definitely want some other options. So the second way to find the area of a trapezoid, and I'm going to take just one of these right trapezoids now, is by taking the height, and I'm going to just remind you, I've got a big base and a little base. Now I'm going to fold this over and make sure that that's, yep. So I'm taking half of the height. You'll see that when I folded this over, I literally got half the height. I'm going to cut these. So I have half of the height. I haven't done anything to either of my bases. And I'm going to cut along that fold. All right. So what I've actually made is 2 more trapezoids. So when I flip these over, remember I have half the height, But then this trapezoid has its longer base is actually the same longer base that I had before, big base. And then I'm going to add that to the other base, my shorter base, a little base. And I'm going to take this whole, the area of this whole rectangle, because it's the same as the area of this whole trapezoid. So I have big base plus the little base times half of the height, and that is the area of the trapezoid that I began with. So that is the second way of figuring out the area of a trapezoid. So we have the area equals big base plus little base times the height divided by 2. Another way to write that is big base plus little base times the height divided by 2, half of the height. All right, and finally, yes, there is another way. Actually, I'm going to show you how that last one worked here. So I can also do it on an isosceles trapezoid. Just so you can see it real quick. Fold it over and cut. So we have big base, little base, half of the height, big base, little base, half of the height, and I have now created a parallelogram. Works just as well as a rectangle. So that was for the isosceles trapezoid. Finally, I'm going to go back to actually use the other isosceles trapezoid that I have here. And this time, I am going to do something a little different. Last time, we cut the height in half. So this time, I'm going to cut both of my bases in half. Now, this one definitely is easiest to show with an isosceles trapezoid because you have two congruent sides. But try it with the other one. See if you can make it work because that's kind of interesting. So I have a whole isosceles trapezoid. I'm going to cut it. I'm going to cut the bases in half because I'm going to cut my little base in half and I'm going to cut my big base in half by cutting the whole trapezoid in half. Now, when I do that, I'm actually going to do that. So now I have half of the little base. Oh, there we go. 2 halves of a little base, 2 halves of a big base. And once again, I'm going to scooch this over and I'm going to attach them. I did not do anything to my height, right? My height stayed the same, but I now have the base of this rectangle is half of my big base plus half of my little base times the whole height of the trapezoid that I began with. So, all right, let's see if I can put that back together so you can see it. So there we go. Whole trapezoid, big base, little base, cut in half, scooch over, flip over, half of big base, half of little base, half of big base, half of little base, times the whole height. And that is the third way to find the area of a trapezoid. So area of a trapezoid, number 3. Area equals big base plus little base divided by 2 times the height. Or an easier way to write that, remembering that a fraction is also a division problem, area equals big base plus little base divided by 2 times the height. All right, now, normally you would be cutting and pasting along with me. So if you were doing that, awesome. If not, try this on your own. If it's not working for you, please give me a call. So your assignment is to cut paper and try to make the area of a trapezoid work for you. All right, and next week I'm going to give you some follow-ups. So if you really don't understand this, let me know. Thank you very much for attending my lesson.